Hey guys, this is going to be a video of me talking about the questions that are in Progress Check A. I don't think I'm going to necessarily give the answers, but I want to. The hard part about these questions is more that students don't understand what it's asking. A lot of times students can do these questions, but they're just not sure what it's asking, and I know that that's the case. If I were to explain how to do this, I think you guys got this. Just sometimes these AP questions can really not make a whole lot of sense. And also calculus is just a new concept, so trying to understand what they're saying takes some time. So in this video, I just want to kind of go over these questions and make sure that you guys understand what the question is asking. And if you get stuck and you're not sure what it's asking for, hopefully this video is helpful. So, question number 1. This one always gets students, and I can definitely understand why. The function f is given by the following function. For how many positive values of b does the limit as x approach b of f of x equals 6? So let me take this expression right here. I'm going to focus on the part where it says for how many positive values of b does the limit as x approach b of f of x equals 6. That's what students don't really understand what it's asking. So let me go ahead and write down the expression. So the limit as x is approaching b of f of x is equal to 6. How many positive values of b? So let's say right here, if I were to take this out, for how many values of x for this function right here, if you were to evaluate the limit at this certain x value, would it be 6? So let me break this down into maybe a more simple function. So let's say that I were to give you guys a graph, and let's say that this graph is quadratic. So we'll just say that this right here is the parent function. We'll say f of x is equal to x squared. Okay, now you guys agree that the range of this function is from 0 to infinity. So is there a point in this function where the value of the function is 6? And yeah, so the value of the function is going to be 6, probably somewhere over here and maybe somewhere over here. So there are two values. So if there's some x value over here, so there's some x equals negative something, and over here there's some x value where x equals positive something, where if I were to evaluate the limit at this x value, I would get 6. And same here. So there would be two values of x, where if I evaluated the limit of this function, I would get 6. That's what the question is asking you. For how many positive values? Watch out for that one. How many positive values right there? Okay? So let me get you started on this one. I have the graph. I have it graphed out right here, just to kind of remind you guys to graph a function. If you're using a TI-84, you could also use Desmos if you need to. But this is this is what I have in my calculator. This is what you'd have to have in your functions, or if you're using Desmos, you can use them too. But notice that I have the function itself. I also have y equals 6. And when I graph them, that's what this looks like. Now, if I'm looking at this right here, again, I'm looking for pretty much where these intersect right here, because that would tell me that that's the value at that intersection. The value of the function is 6. So if I evaluate the limit at those x values, I'm going to get 6 as my limit. But we don't want negative values, so we're going to ignore the one on the far left. So what I want you guys to focus on right now is where that maximum is occurring. You guys need to figure out is that straight line, is y equals 6 intersecting just once, twice, or not at all. So make sure you focus on using this zoom function. So if you go to zoom, there should be a zoom in option, and if you click that zoom in function, I don't have it and I don't know why, but what it will do is if you click zoom in, it will bring you back to the graph with a cursor, and you can use the directional pad and you can move the cursor into that general area, and if you click enter, it will zoom in on that area. You need to verify if that's happening twice there. So I'm going to give you guys this hint. So as far as the question goes, I I don't believe it's going to be 4, because I think it's either going to be 2 or 3. It's not going to be 1. Just remember that the positive values, that's what it's looking at, okay? Positive values. Okay, and I think you guys got the rest of that one. Okay, this question right here, this is similar to question 2 on the homework. A particle is moving on the x-axis, and the position of the particle at time t is given by x of t, whose graph is given above. Which of the following is the best estimate for the speed of the particle at time t equals 4? Remember that speed in a function, if it's a position function, the speed is just going to be the slope at that point right here. The good thing about this function right here, x of t, is that they're all linear or constant functions. Okay, so that could only mean that the speed is either the slope of that line, and you can see that at different times, at 2 different times, the slope of this curve is 0. Okay, you're trying to find the slope of the curve at t equals 4. That's what you're trying to do. Okay, remember, in this case, speed, slope. That's what you're looking at. Okay. Question number 3. A model rocket leaves the ground at t equals 0 and travels straight up from the ground. The height in feet of the rocket above the ground is given by y of t, where t is measured in seconds from 0 to 120. Values of y of t for selected values of t are given in the table above. Of the following values of t, at which value would the velocity of the rocket most likely be the greatest based on the data in the table? Okay, so again, I'm not trying to give you guys an answer. I'm trying to explain the question just in case you're lost. So please make sure that you try the question on your own, and if you're getting lost or need to make sure about something, then come watch the video. But in any case, I'm going to point out some things that might be good to look at. First of all, the answers. The answers are given at t equals 20, 40, 60, and 80. So we can't answer with t equals 100 or t equals 120. So honestly, I don't need any of these right here. Any of these values right here don't really need, okay? Now, we're trying to see which of the following t values, at which value would the velocity, now velocity is similar to speed, they're not quite the same, but we'll get to that later. We'll just say, in our case, speed. Speed of the rocket most likely be the greatest based on the data in the table. So when is the rocket moving fastest in this time interval is pretty much what you're looking at. Remember that speed is a rate of change. It's distance over time. Now if you look at these time intervals, all these time intervals are 20, right? So they all have the same time interval of 20 seconds. They're all equal. So the only thing that's different is going to be the change in your distance over those intervals. So for the first 20 seconds, we went 105. And then from 20 to 40, we went from 105 to 300, so not quite 200 units removed. And then 300 to 900. Okay, that was 600 units. So basically, the change in position is what's going to tell you that right there. So hopefully that makes sense, and hopefully you're getting that, and I'll let you do the rest. Question 4. The position of a particle moving to the right on the x-axis is given by x of t, where x of t is measured in centimeters and t is measured in seconds for 0 to 50. If y of t equals x of t is a linear function, so basically what it's saying that the position of this particle can be modeled by a linear function. A linear function is modeling the position of this particle. Which of the following would most likely give the best estimate of the speed of the particle in centimeters per second at time t equals 10? So here are some options. I think you guys can do this one pretty easily. I'm just going to point out that the speed of a particle, if it's a linear function, is going to be constant. Okay? So, and remember, speed is talking about slope of a secant line, but there's not really a secant line because it's a linear function. So hopefully you guys get what I'm saying. Question 5. Let f be a function given by f of x equals e to the 3x minus 1, and x cannot divided by x, and x cannot be equal to 0. Which of the following equations expresses the property that f of x can be made arbitrarily close to 3 by taking x sufficiently close to 0 but not equal to 0? Basically what this is saying is trying to get you to find the correct limit notation for this expression right here. So f of x, that's the y value, can be made close to 3, while x is being made close to 0. Okay? Give that a shot. Question 6. The function f has the property that as x gets closer to 3, the values of the function of f of x get closer and closer to 5. Same thing, what would be the correct limit notation of that expression right there? Question 6. The function f satisfies the limit as x approaches 3 of f of x equals 6. Which of the following could be the graph of f? I think you guys got that one. You're just trying to make sure that which of these graphs has the satisfies the limit as x approaches 3 of f of x equals 6. Okay, question 8. The graph of the function f is shown above. Which of the following expressions equals 2? I'll let you guys try that one. I think you guys got it. The graph of the function f is shown above. The value of the limit as x approaches 4 of f of x is x equals 4. So the value of the limit as x approaches 4 of f of x is, sorry, let me go back and read this. The graph of the function f is shown above. The value of the limit as x approaches 4 of f of x is, so yeah, you're just evaluating the limit. I think you guys got that one too. The table above gives selected values for a continuous function f. Based on the data in the table, which of the following best approximates for the limit as x approaches 4 of f of x? Okay, so remember that I said be careful about some wording here. There is no best approximation because the limit does not exist. Okay, I just want to make sure we said earlier in class today that you want to be careful with the tables because they don't give a complete picture, but it does look like it's safe to assume here which of the following is the best approximation for the limit as x approaches 4 of f of x. So yeah, just use the table to evaluate it, and I think you guys got it. Question 11. The table above gives values of a function f at select values of x. Which of the following conclusions is supported by the data in the table? So again, it's using that language supported. You should be safe to assume, and go ahead and give that one a go. Question 12. The table above gives values of the function f at select values of x. Which of the following statements must be true? Okay, so this is a good example here of where the question is saying must be true. But you got to be careful. If you're using a table, you don't have a completed picture, okay? And it says must be true. It is not safe to assume in this case right here. Okay, and I think that is going to be it for, I'm not going to go over all these questions right here just because the first homework assignment was just to go through the first 12 questions. Okay, so I hope you guys found this video helpful, and if you guys do, maybe I'll keep doing videos like this in the future.